I'm going to teach you about P1 times V1 over T1 equals P2 times V2 all over T2. This is also known as combined gas laws. And that's the three gas laws put together to create one thermodynamic variable to another. So what happens is as the volume goes up, the pressure will go down because there's less collisions when you increase the volume. And this creates the equation P1V1 equals P2V2 because if you have a smaller pressure and a bigger volume, it would equal the same thing as a more pressure and a smaller volume. On the other hand, as your temperature goes up, your pressure also goes up. And this equation, because when you heat something up, there's more collisions. So this equation is, the equation for this would be P1 over T1 equals P2 over T2. Oh my god, I messed up in this thing. So this would be the same thing as P2 all over T2. So I'm going to give you an example that you can try, and this is with the equation. So a sample of gas has a volume of 4.28 liters at a temperature of 10.24 degrees Celsius and a pressure of 42.2 millimeters of mercury. What would be the volume at a pressure of 34.2 millimeters of mercury and a temperature of 21.3 degrees Celsius? So the first thing you want to do is identify each variable of your equation, and so that you can figure out what you're looking for. So you see your 4.28 liters, and you know that's your volume 1, and your temperature 1 would be 10.24 degrees Celsius. But when you're solving with these equations, you need to turn it into kelvins. And the way to do that would be you add 273 to your degrees Celsius. So as a result, you'd get 283.24 kelvins. And your pressure 1 for this equation will be 42.2 millimeters of mercury. And you don't need to switch it to ATM if the units for pressure are consistent throughout the whole equation and problem. Okay, so now so you have all of your first parts, your volume 1, your temperature 1, and your pressure 1. And now you look for pressure 2 is 34.2 millimeters of mercury, and you have a temperature of 21.3 degrees Celsius, and you need to make that Kelvin, so you add 273. And so we realize that we don't know our volume 2, so that's what we're going to be solving for. So hopefully by now you have this whole variable list copied down. And the first thing you'd want to do is to solve algebraically for V2 so that we isolate V2 and are able to just plug things in. So you would multiply, cross multiply in order to get V2, and then from here you plug in everything you need to into the equation. So with your variable list written down, you look at what you now have and what you have to plug in, and you need to be really careful that you don't accidentally plug the wrong thing into the wrong place. So for your pressure 1, you would plug in 42.2 millimeters of mercury times 4.28 liters, and you plug in your temperature 2, which is 294.3 kelvins. And you divide all of this by your temperature 1, which is 283.24 kelvins, times your pressure 2, which is 34.2 millimeters of mercury. So next what you do is you plug that all into your calculator. You need to be really careful because one mistake could set the whole problem off and it could be wrong. And the result of that would be your final volume. So the way to check this back over would be, so if you're, like I explained in the beginning, if your pressure and volume are inverses of each other, then your equation should be right. So we check this by saying our first volume was 4.28 liters and our second volume was 5.487 liters. So the volume went up. And we look at the pressure, and the pressure went down. So the volume went up, causing the pressure to go down because they're inverses of each other, so you know that you must have done something correct. Thank you for watching.